we were discussing about the efficiency. We were discussing about the efficiency, that the efficiency is the measure of how well a body utilizes the input energy into the output, or how well a body utilizes the input energy to do the useful work, or to convert the input energy into a useful energy store. So this is what efficiency means. So we have a formula of efficiency, and what is it? Basically it is equal to the efficiency. Efficiency is equal to the useful output energy transfer divided by total input energy transfer. As I have told you that all the energy can never be transferred to the useful energy output, so the efficiency of a body can never be 100%. Now in the above topic we were talking about the reduction of energy losses, that how we can reduce the energy losses. It means that if we are reducing the energy losses, it means we are improving the efficiency of a system, right? Are you getting my point? That
Yeah.
how we're reducing the energy losses increases the efficiency of a body, or of a system, right?
Okay.
What is written over here in your notes is a useful device. Useful devices are only useful because they can transfer the energy from one store to another. That they can transfer the energy from one energy store to another useful energy store. As you probably have gathered by now, as some of the input energy is usually wasted or being transferred to a useless energy store, and that is called energy loss, right? So we want to reduce that energy loss. The less energy that is wasted in the energy store, the more efficient the device is said to be. What I have told you is that if there is a less energy loss in a body, it means that that body or that object or that system will be more efficient. You can improve the efficiency of energy transfer by insulating the object, or by lubricating them, or making them more streamlined. What I have told you, that if we reducing the energy losses, it means we are increasing the efficiency of that body, and we reduce the energy losses by two means. The one is insulating the object, or the other is by lubricating them. So this is how the efficiency is improved by reducing the energy losses through insulating or through lubrication. So the next thing is the efficiency of any energy transfer can be worked out using this equation. This equation can be used to find the efficiency of any body. Most of the times efficiency is given in percentage, but you can measure it in simple fraction as well. You might know one thing I want to add over here, that if you want to measure the efficiency in percentage, then you just multiply this equation by 100. If you multiply this equation by 100, you will get the efficiency in percentage. So
Okay.
you might not know that the energy inputs and outputs of a device, but you can still calculate the efficiency as long as you know the power input and output, that how much you are giving the power to a device, and how much you are converting that power into a useful output or into a useful work. If you know these things, you can find the efficiency, because you might not know the input energies you might not know the input in terms of energy, but you can easily know the input in terms of power. So if you know the input and output in terms of power, even you can calculate the efficiency. Then the formula of the efficiency will be a bit different, and it will be equal to the useful power output, and divided by total power output, right? Total power input, right?
Yeah.
Okay. So there is an example. We can do this example. uh, Let me remove these things. Okay. So can you solve this example? Please read it out, and let us see that if you get the concept of efficiency or not.
The a blender is 70% efficient. It
Mhm.
has a total input power of 600 watts.
Right.
Calculate the useful input power.
The output power. Now, can
Oh,
you
output.
Can you calculate this output power?
So you would do. Oh, so it's the other way around. So we know. 1 second. So we know that the efficiency
Yes.
is 70%,
Right.
and then it says we need to work out the input. So then
We
so
want to
then
find
that
the output.
your
Input is given. We want to find the output of that device, of the blender.
so 600 watts is the input of power.
Right.
So then what we would do is, so we know 70% is something divided by 600.
No,
So
you
then
are
what we do,
you are just
700.
you are just confusing this. You keep this formula in your mind and then solve this.
7. Oh, because it's in percentage, you want to put it down as a decimal.
Right.
So
That's
we
what I wanted you
divide
to
by
understand.
100. Yeah. So that would be 0.7.
Right. And it will be
Okay.
multiplied by the input. Why? Let us see this.
Trying to
Uh,
work out the output.
let us see this.
So it'll be 0.7 times 600.
Yes, I have told you that mostly efficiency is given in percentage, and in that case, we have this formula. I have told you that it will be multiplied by 100. Now, in this example, you know that the efficiency is given in percentage. So, what it says is 70% is the efficiency of that device. It is equal to the output. We want to find that output and divided by the 600, which is the input of this body, of this device, and we have this 100 in our formula because we have efficiency in percentage. So when we divide this 100 with this 70, it will become 0.7, and we will multiply this by 600 and we will get the total output. Right? I guess this will be very easy for you now.
Yeah.
So this is clear to you. You don't have any doubts in this problem.
Now, at first I was a bit confused because it was in percentage, but then I got that you had to divide it by 100.
Yes, because in the formula of percentage, we can understand it by
But
in
other
this
than
way,
that, it's
that we
fine.
have multiplied by 100 in the formula if we have percentage efficiency. So that's why we have to divide it on if we move it towards the other side of the equation, right?
Yeah.
Okay. Useful energy input is not usually equal to the total energy output. It's again saying the same thing, that mostly the input we give to a system will never be converted completely to a useful work. So the total energy output will never be equal to the useful energy input, or you can say the total input will never be equal to the total useful energy output, right? So what does this means? It again says that we will have certain losses. So there are examples, there are few examples given over here. We can read it out to understand it a bit more. Basically, any given example, for any given example, you can talk about the types of energy being input and output. But remember, no device is 100% efficient, and the wasted energy is usually transferred to the useless thermal energy stored. That never ever can be a device be 100% efficient. There will always be certain energy losses, and most of the time these energy losses are in the form of heat or in the form of thermal energy losses. Like I have given you the example of bulb, that a tube light or an electric bulb, that how there will be some energy losses in form of thermal energy. Similarly, you can understand it by the example of a laptop. After a certain time, your laptop gets heated up. Why? Because the input energy you are transferring to this laptop, there will be certain energy losses, which is transferred, or some of the input energy is converted to those energy losses which are in the form of heat energy, right?
Yeah.
So basically, electric heaters are the exception to this. Electric heaters are exception to this. Why? Because what is the purpose of electric heater? It is, the purpose of the electric heater is to produce the heat. So it means if it is producing the heat, that heat is not useless for us. Rather, we were demanding that output, or we wanted, or we wished that uh, heat is our output. So this is not the thermal energy losses, this is not a thermal energy loss, rather this is the useful output we are getting from the electric heaters. They are usually 100% efficient. They are, you can say that the electric heaters are 100% efficient, because all the energy they are getting from the electricity is converted to the heat transfer or heat energy, right?
Yeah.
Ultimately, all energy ends up transferred to the thermal energy stores. For example, if you use an electric drill, its energy is transferred. Is its energy transferred to lots of different energy stores, but quickly ends up all in thermal energy store. That even after we getting the useful in transfer, like if we are transferring the energy to a useful energy store, but after a certain time, that energy will again be lost in the form of thermal energy store, right?
Yeah.
Okay, so there are a few more questions in this. Let us see that if we can solve these questions or not. Can you please read these questions out?
So make sure you can rearrange the equation for efficiency and how
Right.
to go at these questions.
So that's how we can solve these questions very easily.
Or shall I continue?
Yeah, please.
Um, a motor is a motor in a remote control car transfers 300 joules of energy into the car's energy store. 225 joules are transferred to the car's kinetic energy stores. Calculate the efficiency for the motor.
Okay, so can you solve this question? You can do it on
So
a paper, if you have a book or a notebook or a paper with you, you can solve it on your paper as well.
uh, Should I get into a fraction? I mean, percentage.
Yes, mostly it is more convenient to write efficiency in percentage, like 70% efficient or 80% efficient or like this. So what you have done is that you divided the output, which is here in our case, it is 225 joule, right? You divided
Yeah,
225 joule divided by 300 joules, because 300 is our input and 225 is our output, right? So when we
yeah.
multiplied it with 100, we get the efficiency in percentage, right?
Yeah, so what I got, I did 225 divided by 300. That
Right.
gives me 0.75.
Okay.
And I did 0.75 times 100 to get it to percentage. That gave me 75%.
Exactly, that was the right answer. So it means that the concept of efficiency is clear to you. So in the next question, it is written that a machine has a useful power output of 900 watt and the total power input is 1200 watt. In a given time, 72 kilojoules energy is transferred to the machine. Calculate the amount of energy usefully transferred to the machine in this time. It's a bit tricky. If you want me to solve this, I can help you out, or if you want to solve it by yourself, you can do it. You can take time to solve it. Should I tell
One,
you that
um,
how it will work out?
yeah, I think it'd be better if you tell me.
Okay. You can see that here in this question, in what data is given to us. We are given the power output, which is useful power output of 900 watt. We have a power input, which is 1200 watt, and we have energy in a given time, 72 kilojoules energy is transferred to the machine, and we have an energy input which is 72 kilojoules. It means 72 into 10 raised power 3 joules, and we want to find the energy output, right? So this is the
Yeah,
data of the question. So what is efficiency? We have two formulas of efficiency. The one is power output divided by power input, and the other one is energy is equal to efficiency is equal to energy output divided by energy input, right?
yeah,
So now we are given with the power output and the power output and power input. So we what we will do is that we will calculate the efficiency by using these powers, by dividing 900 with 1200. So we will get 3/4 will be our efficiency. Now we got the efficiency, we got the input energy, so we will just plug the values of input energy and efficiencies over here, and we will get the output energy, right? So this is how we will calculate the output energy. Did you get my point?
okay. So we do 900 divided by 1200 to
Yes.
get that output energy. Okay.
we to get the efficiency, first we find out the efficiency, and then we plugged in the value of efficiency and input energy in the second formula in order to find out the output energy.
Okay.
First we calculated the efficiency using the powers, power output and power input. We find out the efficiency, and then we use that efficiency and input energy in order to find out the output energy, because we wanted to find the output energy in this question, right?
Yeah.
So you can read this question again and you will be able to sort it out by yourself. Read this question again, please.
A machine has used a power of 900 watts and a total machine input of 1200 watts. In the given times, 72 kilojoules of energy is transferred into the machine. Um, into the machine, calculate the amount of energy useful transferred by the machine in its time.
So you see that we are given the input power and we are given the output power. We use these powers in order to find
Yeah.
the efficiency of the device. Once we find out the efficiency of the device, now it is given that the input energy is 72 kilojoules and you need to find the output energy. So what you did is that you use the same formula of efficiency and use the input energy and the efficiencies you find out from the power. You plugged in those values, cross multiplied those values, and you find out the output energy, right?
Okay.
So this is the simple question. If you have any problem or any doubt in still in this question, you may ask.
Nah, it's fine now. It
Okay.
was because of the wording of the question.
Sorry, I couldn't hear you.
Oh no, it's because the way the question is worded, like how it's written out.
Oh, okay. So that's great. That's great. Okay. So energy resources and their uses. Moving towards the next topic. Uh, what comes in your mind that what must be an energy resource?
An energy source.
Yes.
Like what do you mean by that? Like
I am asking the same question from you. That what does it mean by an energy source?
energy source is where you can get a source of energy from.
Yes, we have discussed a lot about the energy transfer, that the energy is being provided from the one thing and it is transferred to the another thing. But still this point, we have not discussed that from where that energy is coming, where we are getting that energy from. So those resources or those things from which we are getting the energy are called energy resources, and there are different type of energy resources. We can mainly divide these energy resources to a renewable energy resource and a non-renewable energy store. So renewable energy store, what does this mean? As the name suggests, this is an energy source which never gets finished, that it will never be 100% used, you can say. There will always if we can renew it, we can again and again utilize that same thing. And what are non-renewable energy stores or energy resources? These are those type of energy resources which will run out after certain time, that they will be finished after certain time. You cannot utilize them again. uh, I will give you an example of a non-renewable energy source first. Let us say that we burn the fuel in order to, let us say, let me give you an example. Okay, take the example of a car. You put the gasoline oil in a car as a fuel. You use the petrol.
Yeah.
So what happens? That petrol is used as an energy source. It provides the energy to the car in order to move. That energy is transferred to the kinetic energy store of the car. But you see, after a certain time, the petrol gets finished. It will cannot be utilized again. It cannot be utilized over and over again. So it is a non-renewable energy store. It is a type of energy source which cannot be reused or which cannot be renewed, right? So you got my point, that what it
Yeah.
means by a non-renewable energy source.
Yeah, so non-renewable is means that it's only like temporary
Yes,
and it only lasts for a for a fixed amount of time.
yes, for a particular amount of time, and after that time it will be finished, it will run out, right? So this is what it means by a non-renewable energy store. So we see it is written over here that non-renewable energy resources are fossil fuels and nuclear fuels. That fuels are basically non-renewable energy resources. Fossil fuels are natural resources that from underground over the millions of years. They are typically burned to provide the energy. There are three main fossil fuels, which are the example of these fossil fuels are coal. oil and natural gas. You know that the petrol is a refined form of natural oil which we take out from the earth. It is like there are wells of oils which take or which we dig out in order to obtain the oil from beneath the energies beneath the earth's surface. And we take those oils and we refine it, and we separate different types of oil. We convert it into diesel, we convert it into the petrol and all those types, and then we use those oils as a energy source, right? So these are non-renewable energy resources. The same goes with the
Okay.
coal. The same goes with the coal. You are familiar with the coal. We burn that coal and we just get the heat, and that heat is useful for us. So after a certain amount of time, that coal will be finished. So this is also a non-renewable energy store. So these are the energy sources which will run out. All of them will run out one day. They all do damage to the environment. After this is very common thing, that we know that all these non-renewable energy resources, what does they do? They damage our environment. They spread the pollution, like in our cars. Taking the example of cars, we have the exhaust of the car, the silences of the car, right? So what happens? The useless gases are being transferred to the surroundings. So what happens is that our surroundings, our environment is getting polluted, so it will damage the environment all the time, right? But we pay that cost, that we damage our environment, but still they are more useful as compared to non sorry the but they provide most of our energy, but still they are more useful because these are in abundance, and we can take more energy from these energy sources, right?
Yeah.
Okay, now moving towards the renewable energy sources. Basically, these are those energy sources which can never ever run out. Like the energy coming from the sun, the solar energy, it will never ever, it will never run out. Similarly, the wind energy will never run out. The waterways or hydroelectricity, and all these examples will of the all these examples are of non-renewable energy, renewable energy resources, right? So I guess you are following me till here. Tala, are you following me till here?
Yeah.
Okay. So these will never run out. The energy can
Yeah.
be renewed as it is used.
Um.
Yes.
Wait. No, I forgot what I was gonna say.
Uh, Put some pressure on your mind and make it more efficient.
um. What was I gonna say? Wait. No, I'll tell you later on if I
Okay.
remember.
Okay. Forget about that. Forget about that. If the question comes into your mind, you can again ask it.
Yeah, I'll
Uh,
let you know.
okay. Most of them do damage the environment, but in less nasty ways than non-renewable energy resources. That all these energy resources, which are not renewable energy sources, they also still damage the environment, but this is less a bit less damage to the environment as compared to that of non-renewable energy resources. So the trouble is that they don't provide much energy, and some of them are unreliable because they depends on the weather. Giving an example of a solar cell, that in Pakistan, I don't know about the UK, but in Pakistan, most of our house hold electricity is being generated from the solar panels. What they used to do is
Oh yeah.
they just put those solar panels over the roofs of their home, and they take the solar energy from the sun and convert it to the useful electricity. So but
Because
still,
it's really
yes,
over there. It's because it's really sunny over there.
yes, but
But
still,
not, yeah.
you say that you see that it still depends upon it still depends upon the weather. What happens if we have rain for 2 or 3 days? From where we will get that energy? So this type of energy, the renewable energy resources, are not, reliable. We cannot rely completely on these energy resources, because the one thing is they provide less energy, and the other things, these are not reliable, right?
Okay.
So these are the renewable and non-renewable energy resources. Okay, so energy resources can be used for transport. Now we are going to study about the uses of these energy resources, that how we can use this energy which we are getting from these resources. The first use and the foremost is the transport. We have discussed it already, that in car we use the fuels, even in cars and even in aeroplanes, and all the modes of transport use the fuels. So they convert the energy of coming from those fuels to the kinetic energy of that body. It can be a car, it can be any vehicle, it can be any, airplane. Everything just converts the fuel into the kinetic energy of that body, right? So in transport we use these fuels. Here are a few transportation methods that use either renewable and non-renewable energy resources. So we can see that some of these transport modes uses renewable energy resources, and some of them use non-renewable energy resources. So petrol and diesel powered vehicles can use the fuel created from the oil. So this is a non-renewable energy resource. It means that those vehicles which run on petrol or diesel, they use the non-renewable energy resource. Similarly, coal is used in some old-fashioned steam trains. You might have heard about that. That in old trains they used to burn a lot of coal in order to run the engine of that train. So they also use the non-renewable energy resources. And then coming towards the renewable energy sources, vehicles that run on pure biofuels, or a mix of a biofuel and petrol or diesel, can be considered as those mode of transportation which use renewable energy source, right? Tala,
Yeah.
if you have any question or anything, you can ask.
Yeah.
I'm saying that the lecture is getting a bit bored because there is a lot of theory in this topic.
So
So if you want to ask any question.
for what was it? Renewable, right? Yeah.
Tala, I cannot hear you
Yeah.
properly.
So for non-renewable,
Yes.
where it says natural gas, what does that mean?
Sorry, for non-renewable, what do you want to understand? Tala, I couldn't hear you. Can you please repeat your question?
And natural gas, natural gases.
Natural gases. Do you want me to
Yeah.
tell you about natural gases? Okay.
No, like example of it.
That what does this mean by natural gas?
Like an example for one.
Okay, basically, you can have you heard about compressed natural gas, CNG? Have you heard about that? Some vehicles run on CNG, or have you heard about LPG?
No.
Okay, do you know that we used to cook, and for our kitchens there is a gas supply?
Yeah.
So
Yeah.
So that gas supply can be an example of natural gas. We used to burn that gas in order to convert it into a useful work done. So we are inputting that natural, that is the type of a natural gas. Similarly, there are certain vehicles which run on CNG, and it is CNG is basically an abbreviation of compressed natural gas. It is also type of natural gas. So similarly, there is another type of natural gas which is called LPG. It is also used in kitchens in order to burn or in order to cook food, and LPG stands for liquid petroleum gas, right? So all these types are of natural gas. So yeah, now you are clear with this natural gas.
Yeah, I get it now.
Okay, so moving forward, and for heating, energy resources, basically what we are studying is that we have studied that there are always some source of energy from where we get the energy. Then we have discussed that we use this energy in different type of useful works. So in that we have two categories. Basically, we use our energy for transportation and for heating. In transportation, we have seen that we use both renewable and non-renewable energy resources, in which we have seen that those vehicles which use petrol and diesel in order to run, and those vehicles use non-renewable energy resource. Similarly, those old-fashioned trains which used coal also use non-renewable energy resources. And then there are certain vehicles which run on biofuels. They work on renewable energy resources. Similarly, we use these energy resources in order to heat. And for heating, again, we have certain type of energy resource, certain type of systems which use non-renewable energy resources, and certain type of systems which use renewable energy resources in order to get heat. So first of all, natural gas. Natural gas is most widely used fuel for heating homes in UK. The gas is used for the heat to heat water, which is then pumped into the radiator throughout the home. Similarly, there are some gas geysers in order to just heat the water, which is used for the bath and or for the showers. So what they are using the natural gas. Similarly, coal is commonly burnt in fireplaces, so this is also a non-renewable energy resource, and it is used in order to produce heat. Similarly, electric heaters which use electricity generated from non-renewable energy resources. This electricity which we use in order to run the electric heaters, basically this electricity is also generated through non-renewable energy resources, which includes coal and some other energy resources. So this is how we use these energy resources in order to produce heat. Similarly, there are certain renewable energy resources which can be also used in order to produce heat. A geothermal or ground source heat pump uses geothermal energy resources to heat the buildings. Similarly, water heaters use solar energy in order to heat the water. Similarly, burning biofuels are using electricity generated from renewable energy sources can also be used for heating, and they use renewable energy resources. So I'm sure that you are clear with all these concepts.
Yeah.
Okay, so there is a theoretical question over here, and I will leave it for you as an home assignment. You need to write down whether each of the following are renewable or non-renewable energy resources. You will look in it. It will just take your 5 minutes, and then you will discuss it with me that whether the tidal power and natural gas and nuclear power and biofuels, or whether they are renewable energy sources or non-renewable energy sources.
So
Then
I have to memorize them.
yes, I want you to just have a little introductory paragraph about all these four type of energy resources. That what is biofuel, what is nuclear power, what is natural gas, and what is tidal power. You can use the internet and then memorize it, and then we will discuss it in the next class, right?
Okay.
So, moving forward, there are some other energy sources. The wind, we can use the wind energy. You know that there are some windmills you have seen on the internet or in the television. They use the wind energy in order to produce electricity. Similarly, we have discussed the solar energy and the geothermal energy. We will. This is a figure in which you can see that the wind energy is being converted to the electricity. So in the next class we will discuss about these types of the energy resources in a bit more detail, about the solar cell and geothermal power. Please read these types a bit, a little, so that you can understand these types of energy resources in a bit better way. So we will continue from here on, and if in the next week you find any problem in your college, you can let me know, and we can take the class in the week, or we can discuss it on the WhatsApp as well, right?
Okay. Yeah. So,
So I guess let us wind this topic over here, because there is a lot of theory coming ahead, and I guess the lecture is getting boring, so it will not be more effective, and we
yeah.
cannot use our energy more efficiently, I think.
Okay, then that's
Uh,
fine by me.
okay, Talam, then see you next week. And still, if you find any problem in the class in your school, you are more than welcome to ask me on the WhatsApp, right? You have my number, so we can discuss it over here.
Yeah, and I'll tell you about the timings if I need to make any changes.
Uh,